Okay, so let me introduce myself first. My name is Reina Alfred. I've been in UMS for almost 26 years, 27 years. If you want to contact me, this is my number. If you want to email me, this is my email. And if you want to come for face-to-face consultation, you can come to my office in FKJ, Block A, ground floor. So you will see this center, Creative Advanced Machine Intelligence Research Center. Okay. So for your information, I started my study in Kudat, tips of Borneo, and then after Form 3, I went to Labuan for the boarding school. So after Form 5, I pursue my study in Brooklyn, New York. So we study computer science. So all the way from bachelor, master, and PhD, I continue my study in computer science, but slowly, if you can see in Polytechnic, we study a general computer science, but I started to develop interest in AI when I continue my study in master in Western Michigan. And then finally, when I did my PhD, I focused more into knowledge discovery and machine learning. Okay, so that's a bit of myself. My research interest is more into data mining, information retrieval, text mining, anything to do with knowledge discovery. So this course is a bit lighter compared to machine learning, but still we have a lot of calculation that we need to cover here, especially when it's dealing with performing ranking or representing the document for us to measure the differences or similarity between the query and also the document. Okay. So what is the course objective? Okay, by the end of the course, you should be able to explain what is information retrieval, the basic concept of information retrieval, what are the four main components in information retrieval, and you also need to be able to build a simple document retrieval system. So you may be confused with ChatGPT or text mining or natural language processing, but you will learn all those things later on, some on your own, but in this course we will focus on how do we retrieve information effectively. Effectively means we need to get higher accuracy and what we call it, reduce the number of error. Okay, why do you need to study this course? To pass or to complete your course, your data science. Okay, so before that, have you Google or have you typed this, what is information retrieval? Okay, so in our daily life, basically we are doing this process, finding out the relevant information about anything that you want to ask. But most of us go to ChatGPT because it gives us the direct answer. So the differences between ChatGPT and Google is that Google allow you to search for information, but ChatGPT allows you to perform Q&A, okay, or text summarization or topic modeling. So which is different from this course. So this course is more into how do we represent document because document is considered as unstructured. So in this slide, we are saying that unstructured. Okay? Unstructured refer to any document or any data that is not in the table format. So you have study database, right? So database is in structured format where you have columns and rows. But when we talk about unstructured data, it refers to text document, but not limited to text document. We could have video, or we could have images, okay? Or we could have audio, okay? So this is considered as unstructured data. And one of the reasons why we need to look into this is that 80% of our data now is in unstructured data. So if you look at this is like database, this is your DB, this is your web. Okay, so most of the data that we have at the moment coming from the web. We have bloggers, we have YouTube, we have Netflix. So we have a lot of things that we use daily coming from the web. And if you do research, then you need to analyze data from the database. So they're coming from the database. So this diagram illustrates the differences between structured data and unstructured data, where large volume of data coming from here, 80% of them. Okay, so this is the distinction between unstructured and structured data. So structured data, they are coming from your database. So they have numbers, date, string, and only 20% of them that we use. Okay, no, 20% of them from the overall data that we have. So this one require less storage and easier to manage. Okay, so if we compare to unstructured data, we cannot display them in the row or column because, for example, document coming from in a set of corpus, so a set of document. We also have audio, video, email, spreadsheet, and so on. So thus they require higher storage and then more difficult to manage and protect with legacy solution. Legacy solution refer to old technology. Okay. And if you look at the search engine also, we have a lot of search engine. So IR become the backbone of the modern search engine. For example, at the moment, Google is the top search engine. So if you see that Google is the most popular search engine with a stunning 81.5% market share, followed by the Bing. Bing coming from where? From Microsoft. Okay. So have you heard about us.com, Yandex? Google Scholar is used if you want to look for research paper or scientific paper or people who do research. So they summarize the paper, they have the citation, coding, and so on. So Baidu is the Google version of China. Okay. Never Yahoo. Yahoo is one of the search engine that was most popular a long time ago, but they do not have R&D people. So Google is very clever. They have a lot of R&D people here doing a lot of things. How do they make the search engine more effective and more user-friendly? Okay, so the IR become the entry gate for you to know more about how does Google do things, how do they get your query, and then how they rank the document, how they represent the document in the system for you to retrieve the document. Okay. We also use IR in order to personalize recommendation. For example, we have so many e-commerce platforms, for example, Amazon for you to buy item or anything online, Netflix, movie, Spotify music. So they rely on profiling. Profiling means every time you log into the system, they will do profiling for you. They will keep track what you access. They try to build a profile based on your activity or based on your behavior. Then they will recommend item that is almost similar to your hobby. Okay, so for example, like this guy view one item here, they will do profiling for you, and then this recommendation will select all those items that is highly related to this or more similar to this, and they will recommend that item to itself. So this is to improve user experience in using the e-commerce platform that they have. Okay. So if you are wondering the differences between my course and Dr. James' course, and also this is for 4th year, you will be taking this one. So these are the 5 row. How do we differentiate these 3 courses? Okay. So for the goal for IR for this course, we basically want to know how to find and rank relevant document. Okay, so this is referring to all the set of document that we have on the web. Okay. In contrast, if you look at the text mining here, so basically you want to extract the content of the document or pattern that exists in that document. So this is used for clustering later on and also classification. Okay, so if you but of course next semester you will learn about this natural language processing, because this is one of the intelligence that we say part of human being. Okay, the ability to express your thought in a language. So for a system to be able to communicate with us, they must understand what we talk about. So that's why this course talk about understanding and generate language, natural language. Okay. So the input for the system for the IR, we refer them as query. Okay, and also we need to feed all these set of document. So for us to select the document that is most relevant to your query. So basically you want to look for certain concept or certain document. So they will give you that document depending on the detail of your query. Okay. For the text mining, you just give them large set of document. So corpus refer to set of document. Okay. And in natural language processing, we just need human language, the speech, in terms of speech or text. So they want to study the sequence, the context on how the word is being used, what is the meaning, and so on. So they look at the meaning here. Okay. So in terms of output, so for IR, we expect to have a ranked list of documents. So this ranked list of document is based on your query. Okay. And in text mining, we are looking at a group of documents. So since we are looking at the pattern or the knowledge that exist or reside in the document, we are looking at the pattern or the cluster that we have. Okay. So lastly, for the core technique, so we are looking at the indexing. How do we index the document? How do we perform ranking? And then embedding. Okay, we will study these three. Of course, we will apply some of the technique that we have here, clustering and topic modeling here, in order to show the application of information retrieval or the document representation that we have in IR. Okay, so if you are taking this course next semester, you will learn how to do tokenization, parsing, name entity recognition, translation, and language modeling. Okay, so this is where ChatGPT falls. So to be able to communicate, to perform Q&A, summarize, topic modeling, and so on. This one is more into classification. You want to do sentiment analysis and so on and so on. Okay, so if we compare with IR, so we are looking into searching, Google search. So based on this table, we should be able to differentiate between IR, text mining, and natural language processing. These are the three main causes for unstructured data. Okay? So a lot of our data now reside on the web, which is 80%. So outside there, we need more people who are interested in doing this research. Okay, so like I mentioned just now, we can do profiling based on the user behavior on the web. So we can design the user center profiling. So we build profiling for individual user that we have. We could also use IR for interdisciplinary application in which we use cross-domain information retrieval. So for example, from healthcare, going to legal, and then social media and so on. So we want to have this system to be applicable across numerous domains. Okay. Okay. So the past 3 slides show the importance why we need to take the course, right? Not only to pass or complete your curriculum, but to be able to use them in the future in the industry that require this. Okay, for the course learning outcome, the first one is ability to explain the basic concept and technique. So this one will cover the knowledge. Okay. So you will be tested that one in the midterm and also the quizzes. So mainly in the quizzes lah. So most of you will have full mark here, but if you miss the quiz, then there is no replacement. So try not to miss the quiz. Okay. Sometimes if I look at the performance of the whole class, I will have extra quizzes for you to replace your quiz. Okay. And midterm, of course, it will be 90 minutes testing your ability to apply the knowledge that you have learned to solve the problem. So everything is in calculation. So you don't have definition because all the definition are tested here. Okay. And the second one is the ability to demonstrate the differences between unsupervised and supervised. So unsupervised, you have learned in data mining and warehouse. This is clustering, this is classification, right? So this is clustering, and this is classification. Okay. So you will have a practical lab. So The practical lab is very easy. You may also have a project. So the project is actually implementing what you have studied in this course and to show how it works in the system. How do you represent the document? How do you measure the similarity? How do you perform ranking? And finally, how do you present the result to the user? Okay. And then lastly is basically apply what you have studied in 12 weeks and then answer all the questions that you have in the final exam. Okay, so most people will get full mark here, but 70% of you will have less than 50%, less than 20% here. Okay, so if you look at this one, this is your course assessment. So for the quizzes, no problem. Assignment, no problem. The problem only exists if you cannot do the programming assignment. Okay, the midterm also depends on problem solving. Similar to this, you need to be able to do programming. And then lastly, most people will get this one 50% and above. Okay, so 50% and above. So if you want to get A, you need to get at least 30% here, right? But based on experience, 70% of you will get 20% and below. Okay, so to get A, that means you need to get 60% here. Okay, so for me, the course is not difficult. It just need consistency in attending the class, the tutorial, and never forget to take the quiz, submit the assignment, the lab practical, and so on. Okay. So this is the course schedule. We supposed to meet yesterday, but yesterday I was not in KK and also fully occupied. So today I'm free. So that's why we meet online. So I don't want to miss the week number 1 because we only have 14 weeks. So we have 1 week for midterm, 1 week for the final semester. So we only left with 12 weeks. So this is week number 1. Okay. So this is the study plan. So today we will cover this. So should be okay. No problem. So next week you will study this. So I will provide pre-recorded video for you to look at this one, and of course there'll be a quiz to at least make sure that you watch the video. Okay, and so for this one is more or less like happy hour, and then from here to here we will have a very tense week in which we will study all the formula, how to apply the formula, and so on. Okay, so based on the comment from your senior, they know how to do the final exam or midterm, but they do not have time to complete them. So that means you need to be very, very fast and know what formula to use to solve the problem. Okay, so if you're looking for reference book, I recommend you to take the first one, Modern Information Retrieval, or you could look at this book. So I have the link here. I have shared the slide in ITEL. So if you want to get the soft copy, you can click on the link here, and it will allow you to download the PDF file for this one. For this one, you need to buy online. Quite expensive, 200 something page. Okay. So this book is written based on research finding. So a lot of things that we will study will be based on research. So based on the research, they look into all the formula that we can use in order to perform. First, how do we represent the document in the system? And second is, how do we compare? How do we measure the similarity? And the third one is, how do we perform the ranking? So these three things, how do we represent document and the query? And then how do we perform similarity? And how do we perform ranking? These three, if the end of the course, you know how to do it, you should be okay for the next course. Okay. Okay, so the book that we are using, which is this one, I have the hard copy here. If you want to borrow photocopy, sepatutnya tidak dibenarkan lah. Tapi if from your senior also they want to have reference, they borrow my book lah. Okay, but if you have money, you should buy one because this one is a very good reference book for all of us, because later on, if you want to do more research, this book can be a good reference. I have requested last time the book. You can go and check, but if ada pun dia very limited, some maybe 3-4 macam tu lah. So first come first serve lah. Okay. Okay, so the way we handle the course will follow the book punya subchapter tu, so which is this one, so modern information retrieval. So we will focus on the algorithm and technique used in information retrieval system. So because this technique is used by the librarian and or the information science researcher. So last time we do have this course or degree called information science. So this is for those people who will work in library, assisting them on how do we arrange the book, how do we retrieve the book, and so on. Okay. So any question so far? No, no question. Okay. So like I mentioned just now, all the online lecture will be recorded. So it will be uploaded into YouTube, so you have time to refer to them. But those lecture that we carry face to face, I will also upload recorded session, but from the past. So you still have the chance to view them, but maybe in different style or different audience. Okay. So today, what we will cover, we will look into some of the basic concept that we need in order for us to proceed to the next chapter. So in this lecture, notes number 1, I will review what is IR, what is the actual problem that we want to look into, and what you are expected to learn from this course. Okay. Okay, so the outline for the first lecture, I will go into the IR itself, and then what is the actual problem that we are trying to solve in IR, and what is the IR system looks like. And then finally, we look into the web, how the web influence or become the catalyst for the IR that we have at the moment. Okay, so if you look at the differences between our world and the system, right? So our world, we can see things, we can talk about anything, any abstract, and then we can write a document, or we can edit a film, we watch video, and so on. But all those things, when we want to store in a computer system, we storing them in binary format, right? So similar to what we have in IR or information retrieval, we want to know how document will be represented in the system so that it is easier for us to retrieve the document. Okay? So only by knowing how we represent document, then we will be able to manipulate the data that we have. Okay, so IR deal with the representation. How do we represent the document, and how do we store them in the system, and how do we manipulate them, organize them, and then how do we access all those information for the purpose of retrieving document. Okay. And the early goal of IR, how they organize document is by using indexing. So for example, like this is your document. Let me change the color. So this is your document. So for them to maintain like a keyword or index, they only extract the main keyword from your document, and they will put in the index file, which is consisting of all the keyword that we have. So based on the keyword, then you will be able to keep, this is what we call the hash table. Okay, you learn about data structure, right? So how do we maintain a table? How do you maintain a tree structure? How do you maintain a hash table? So for this one, for the IR, we use hash table to represent the index that comprises of all the keyword linked to the document that we have. Okay. So for nowadays, research in IR includes modeling, web search, text classification, user interface, data visualization, filtering, and language. So the area of research nowadays going into a very specific area. So if you want to do modeling, for example, topic modeling, or you want to do sentiment analysis, or you want to do clustering, so all of those you can study here. And then the web search is more into IR. Text classification is more into modeling as well, similar to this. Okay, how do you design user interface, which is more user friendly? Okay, and then how do you visualize your data, the content of your document, and how do you perform filtering, and then language analysis, and so on. Okay, so many areas we can go into. Okay. So let's take a look at the where does the IR come from? Who started this area of research? So I started in 1950s. So started by this German-American researcher. His name is Hans-Peter Lund. So he's a researcher in the field of computer science and library. Okay. We also have this Eugene Garfield. So in the 50s, there are 4 people who have started this one. Hans Peter Lund and Eugene Garfield, the founder of the Institute for Scientific Information. Okay. And this guy, I cannot find his photo, but he was an American computer scientist, more into business data processing professional. And lastly, this Calvin Moore. So he's the one who coined the term information retrieval. Okay, so these are all the pioneer in the IR world. And then in the 1960s, we have this Joseph Becker and Robert Hayes. They published the first book called Information Retrieval. Okay, so they're looking into what information can be stored and what can be retrieved. And then in the late 60s, we have this Karen Jones, a woman behind the concept of inverse document frequency and index term weighting. This one. So we will study this one. So this is the professor who introduced the TF-IDF, Karen Spark Jones. Okay, so you will learn this one in this course. We also have this Sultan, a professor of computer science at Cornell University. So he introduced this vector space. Okay, so you will also be learning vector space, TF-IDF. So these are the people who introduced the concept. Okay, in 1971, Jardine and Van Rysbergen introduced cluster hypothesis, clustering technique. So this is also called unsupervised technique. Okay, so this is the professor of computer science at the University of Glasgow, where he founded the Glasgow Information Retrieval Group. Okay, so this one is just to illustrate that the document that we have can be clustered according to the content of your document. Okay. In 1978, we have the first SCM special interest group on IR conference. So Jack Meeker is a professor emeritus, founding chair of the Department of Computer Science at the University of Maryland. Okay, so he organized the conference, the first conference. Now we have, this is the first one. Now we have around the 50th conference, I think. Yeah, 50th conference. So 50 tahun already lah. So started in 1978. Okay, and the next year, Van Rysbergen published a classic book entitled Information Retrieval. So they focus on the probabilistic model. So we will learn also this model later on. Okay. And in 1983, they introduced this vector. So this vector illustrates how the sentence or your query can be measured. How far is it from the document that we have in the system? So they use the vector to illustrate for query that is similar to the document, they should be pointing at the same direction on the same plane X, Y, Z. Okay. So for example, like this is a global topic. This is the sentence that we have. So the distance would be this. Yes, so there'll be some number here. So we can measure the differences between one sentence and another sentence at the global or the document that we want to refer to. Okay. So, so our task is if the document and the query are the same, then the angle should be going to 0, right? 0 degree. So pointing at the same direction. Okay, so we will learn this one as well. Okay, so the reason why we want to go back and look at all these people, because we want to know how the IR technology evolved and who introduced this one, so that when we study this, at least we know that we need to study this because this is part of the evolution of IR technique that we have. Okay, so since that we have a lot more, we have new method, for example, vector to vec or bird and so on. So we will study that one later on. But this one just to give you the idea that all those things that we have at the moment, new technique, they are all based on all this pioneer researcher idea. Okay. So last time this topic IR is very popular among the librarian or the information science officer, where we look at how do we catalog all the books, and then we use the subject heading, the keyword, or the query operator to retrieve the document, and then how to represent them to the user in a user-friendly environment. Okay. So the problem that we want to solve in this domain is that given a query, how do we rank the document so that we can measure in terms of relevancy? Okay, so for example, let me show you this one. This is you, right? So if I ask you to search for a topic that you never read before, so you don't know what query you want to key in, right? So this is the collection of document that you have. This is the retrieval system. Based on the query, they will access this document, and then they will rank the document based on your query, and then it will present to you. So let's suppose you have no idea, then you just type any keyword, then it will give you a set of document. So if you have question mark here, how do you know that the document presented to you are relevant to you if you do not know any background about the subject? All right. So that's why they say if you want to do project that you have more experience before, or if you have more knowledge in terms of doing the project. So it's better to do something that you are familiar with or you want to know more about that. Okay. So this is the IR problem. This is you present the query, and then the problem is how do we make sure that we present a list of documents that are relevant with respect to your query that you presented here. That is the problem that we want to look into. Okay, so for example, like this, if you type something like find all documents that address the role of the federal government in financing the operation of the National Railroad Transportation Corporation. So if you type your query like this in a Google, you will not get a good answer. But if you type this query in a ChatGPT, you will have a better answer. Okay? But the problem is we are not looking into ChatGPT, we are looking into Google. Okay, ChatGPT, they are best used when you instruct them to do. But in Google, we just type in a keyword. So the keyword that we want to look into here is what the role of the federal government. But we have some other things here in financing the operation. And then we also have the National Railway Transportation Corporation. So we have first part, the second part, and the third part. Okay. So So if you want to use Google search, you will have a problem determining which document is the most important part. So, but don't worry, we are looking at the degree of relevancy. We are not looking at exact matching. Okay? So that's why we learn IR, because IR, they're looking into how do we maximize the degree of relevancy with respect to the query. Okay, similar to in classification, we want to increase the accuracy of performing classification. So similar to the clustering, we want to reduce the differences between the member of the cluster that we have. Okay, so when we talk about the IR problem, normally we will look at what information we need. So we will convert them into query, right? Okay, so the query that we type or the keyword that we want to express here, depending on what we know, what is your knowledge about the subject. Okay, so if you do not know about the subject, then you don't know how to put in here. And another issue is how many keywords that we should type. So some people type the whole paragraph. Some people type one sentence, two sentences. Some people just type 3 words only. Okay, so from the information that you need to transform them into query, and then from the query, your query will be passed or processed, and the relevant document will be presented to you. Okay, so it should be useful or relevant to the user with respect to the query that we have. Okay, so in short, that the IR problem is that the key goal of IR is to retrieve all the items that are relevant to the user query. So this is very abstract because the term relevant will be different from different people. So different people will have different perception because they have different knowledge, different background, and so on. Okay, but in addressing this one, so that's why we need to know how to. What is the first one? How do we represent? Right? How do we represent the document and also the query? And then how do we store them? Okay. And then the third one is how do we what? Ranking. How do we perform ranking? Based on measurement. Okay. Represent, store, manipulate, and then you perform the ranking. Okay, so the notion of relevance is the central importance of IR. So it goes to statistics. Okay. Okay. So once the user have key in the query, you may have entered a poor query or a better one. So depending on how you think about a certain subject. Okay, so maybe the user have more knowledge in this area, so they will be able to key in the right topic. If they do not have the right background, then they may have very general keyword. So it all depends on the background knowledge of the individual. So we keep searching and querying, and then we browsing and navigating. So the process looks like this. So this is you do the searching, and then the document given to you. So you do the browsing again, searching, and so on and so on. So you will stop when you think the document that given to you match to your requirement, or you satisfy with the document that you are looking for. Okay. So if we compare with the database and also the information retrieval, so information retrieval, they are looking into the keyword, and then they will give you the set of document depending on the degree of relevancy. But if you compare to database you study about structured query language, right? So you type select this from this table, where match the condition or group by, and so on and so on. So there must be exact matching. So it not depend on degree of relevancy, but must be exact matching. Okay? So that's the differences between database and also data retrieve in database and data retrieve in the information retrieval. Okay, so to summarize, so first we have this web crawler engine where it will gather all the data. So basically this is your web. So this is your web. So we will put out this web crawler. Web crawler is just a program. Okay, so you give them a seed URL. Seed URL are referring to an entry point in the web, and then it will crawl the web. If it has link to another web, it will continue and so on. So the web crawler will gather, basically send you the document, and then based on the document you build the indexing. So the content of the document will be represented by a keyword. So the keyword is used to be will be used for indexing. So this is your inverted index. So basically you have all the document here. So this is your keyword. Okay. So the keyword will point to the document that we have. So for example, this one we have 3 document. This one have 2 document and so on. Okay, but by using one keyword only. Okay, so once we have this indexing process, so you will submit a query. This is you, and of course you will have to pass the query or explain the query, or because sometimes if you modify the query, you will have greater number of hits, right? Greater number of match. Okay, so maybe it will be automatically expanded or reduced depending on the algorithm that you use. Okay, and then we perform the ranking and retrieval. Okay, which is here. And then finally present to the user. See, so the process that we are looking here is here, the query passing and also the ranking and also the retrieval. Okay, but if we look at a smaller scope, we zoom in. Okay, so we zoom in. So this is a user interface. We submit the query via the interface, and then we perform query expansion and modification. We expand or normalize. Normalize means we simplify the word that we have. Okay, and then we perform the retrieval based on the degree of relevancy matching to the keyword that we have, and we perform the ranking, and then we format the presentation to the user, and we update the indexing that we see. Okay, so this one is here. Okay, in the Google, when you ask something, they will present to you up to 10 documents, right? So you can go for more. So they will record which one you click, because they will rank the document 1, 2, 3, 4 up to 10. But the number one not supposed to be the top one. Top document means important to the user. The user may click on document number 5. So when you click the document number 5, it will update here. So they say that, okay, based on the user punya behavior, they click document number 5. So that means document number 5 is more important compared to document number 1, 2, 3, 4. So they will update the indexing process saying that this is, we put more weightage on document number 5. Okay, because document number 5 seems to be more relevant compared to document number 1. Okay, so these are the whole process that we want to look into this course. So how do we perform query expansion, modification? How do we perform retrieval process? How do we perform the ranking? And then so on. Okay. So these are the 4 main components that are very important. So user query, document representation, retrieval process, ranking, and feedback. So if by the end of the course, you are able to interlink all this concept and then explain in detail how they are performed and how it works and so on. So you are on the right track. Boleh cari kerja lah di luar. Okay. So based on our interaction with industry, information retrieval, ChatGPT, text mining, natural language processing, all these 4 courses are high demand in the industry at the moment. Okay. Of course, you also learn about machine learning. You study about big data. So you have all these necessary skill to be employed by industry and get good pay salary. Okay. Okay. Any questions so far? What's the time now? So if you are still there, can you type number 8? Number 8. Okay. At least someone listening loud. Okay. So we still have a few more slides that will conclude the course, the first session that we have. Okay. So this is the pemangkin. 9 minus 1. Okay. 8. Okay. So this is the pemangkin for IR, the web, because we have so many data reside on the web. Okay. So the web search is today the most prominent application. So how do we actually keep up with the ever increasing number of unstructured data? So we need to be able to know how to do ranking, how to do indexing, and so on. So there are a few major impacts of the web on the search. Okay, the first one is the crawler. So we have a lot of many technique on how to perform the crawling. So now they are trying to avoid this crawling by saying that you are not a robot. Okay, so you have to log in and so on and so on. But most websites are not protected, so you can still crawl. Okay, so this is you, not you lah, the algorithm. Okay, you give them the seed URL where you start. Okay, so it will crawl and then continue to the next page and continue to the next link and so on. So you send to the storage and you perform the indexing. So this is the user. The user will perform the query and fetch the data, and they will perform the ranking and present to you. So there are a few techniques on the crawling that we have. The second major impact is the size of the document that we have. So we have the volume of user queries submitted on a daily basis pun increasing. So therefore, how do we scale our system to accommodate higher number of queries? Okay, the third major impact is we have a very large data. So based on this data, we can collect, we can organize, and we can do some prediction. Okay, but all the content must be extracted from the unstructured data for us to be able to perform some prediction. So that is the impact. The fourth impact is the derived from the fact that the web is also a medium to do business. So from here we can extract or do profiling about certain people. So we can do product recommendation. At the same time also we can see what is the market trend, what item is popular, what trending is popular. So we can extract from the web as well. So this becomes the source of information for all the business enterprise that we have. But the fifth major impact, we also have this web spam, okay, where when you look for certain information, you will be directed to a spam page. So it will collect your information and then do spamming on your desktop. Okay, so some of the security, some of the issue that we are looking into is that we look into the security, privacy, copyright, and patent right, depending on what area you want to be in. So you can look into security, cyber security, or you want to look at how do you ensure privacy for all the users that using the web, and also how do you keep track who own what item on the web. Okay, and since we have this a lot of information we want to process, so how do we scan them? How do we digitize them, because some of them are not in the digital format. Okay, so if you look at the process that we have talked about, so we look into today is the introduction, right? So we have next week we will cover user interface for search, and then we look at the modeling, retrieval evaluation, how do we evaluate them, relevant feedback. This is the classic IR. So we also look at the document language properties, the query properties, text classification, and so on. Okay, so these are the topics that will be covered in this course. So the advanced topic for indexing and search, parallel and distributed, we will cover depending on the time that we have. But these are some of the techniques that you can study. but the sequence of our course will follow this course content. Okay, so a lot of calculation. Okay, so any question?
So far, no, sir.
So far,